Okay, so this is something we learned kind of in the beginning. We're going to be given a function. So this function happens to be f of x is equal to x squared minus 2x. And this time when we're asked to find f of 2, notice instead of the x, there's a 2. So we're just plugging in a 2 wherever there's an x into our function. So with this one, we're going to have f of 2 is equal to, wherever there's an x, I'm substituting in a 2. Now it's important to use parentheses, guys. So 2 squared minus 2 times 2. So then going through this, simplifying the order of operations correctly, 2 squared is positive 4. And then we have negative 2 times 2, which is negative 4. So 4 minus 4 is 0. Does everybody understand that one? I just plugged in 2. Yeah, are we all good with that? Okay, awesome. So f of 2, guys, f of 2 is equal to 0. Now this is different though. On the test you're going to see both, I can promise you that. So this time it says find f of x is equal to 2. Now this time it's not f of 2 like in this one, it's f of x is equal to 2. So instead of an f of x there, it's equal to 2. So we're going to have 2 is equal to x squared minus 2x. Does everybody see how instead of f of x here, we're writing what it's equal to 2? And now we'll solve. Now keep in mind, guys, be very careful with this one. We have a bx, so we can't just square root both sides and go. Okay, this one is different. It's a quadratic, degree 2. So quadratics, before you can solve them, you have to make sure they're equal to 0. So I'm going to subtract 2 from both sides. So that gives me 0 is equal to x squared minus 2x minus 2. And now with this quadratic, we can solve using factoring if possible, or the quadratic formula always works, right? Since we're solving, we could use the quadratic formula. Do I need to go through the quadratic formula, or do you feel okay? I think you guys are getting really good at it, actually. So I'm not going to go through it. Awesome. Domain and range. You will see this on the test, guys. You will see this on the test. So domain is left and right. We're talking, so left and right, and we're talking on the x-axis. Where's our function growing on the x-axis? Where does it start? Where is it growing to? Now we're talking left and right, not up and down. So left and right, where does that function start? At what value on the x-axis? -5. And it's growing that way to positive infinity because of the arrow. Now, if you write your answer like that, you get it wrong. You've got to put in your brackets and parentheses depending on the problem. Did it include -5? Open circle, so it needs to be a parenthesis. And then infinity is not an actual number. We can't peg it as a number, so we always put parentheses around infinity. Now range, shift your eyes. Now we're talking up and down. So up and down, where's my function starting? Where's it growing to? So up and down, at what value on the, this is the y-axis, guys. On the y-axis, where do we start? -4, and it's growing positive infinity. So -4 to positive infinity, did it include -4? Open circle, so you put a parenthesis, and then infinity, always parenthesis. You're going to see domain and range on the test, promise, okay? And it's on the review, so it'll be good. Okay. All right, looking at this one quickly, this one's kind of tricky the way it asks on the review and on the test, so I want to just quickly touch on a few things. So it says, given f of x is equal to -3x squared plus 3x, find the x-intercepts. So guys, to find the x-intercepts, that's when y is equal to 0. So it's opposite of what you think. It's when y is equal to 0. So we'll plug in 0 for y and find the x-intercepts. So we'll have 0 is equal to -3x squared plus 3x. Now we can solve the zeros, right? We can solve for the zeros. It's a quadratic. We could use the quadratic formula. Or this one actually factors from the beginning. This one's easier to factor. I'm going to quickly factor this one. What's in each term that's in common? A 3 and an x, and there's a negative in front. So I'm going to factor out, it doesn't matter though if this one, it happens to not matter. I'm going to factor out -3x, and then left in parentheses would be x minus 1. Now, aren't those linear? So I can say each of those equal to 0 and solve. So I would set -3x equal to 0, and I would set x minus 1. Did I do that right? Yes. Okay. And I would set x minus 1 equal to 0. And I'd solve for x in each case. Does that make sense, everyone? Yeah, are we all okay with that? Okay, so I would find my 2x intercepts. Now, y-intercept is when x is equal to 0. It's the opposite of what you think, so you'll just plug in 0 for x. So look, anytime you're asked for a y-intercept, plug in a 0 for x. So we plugged in 0 right there and right there into our function. What do we get as an answer? Negative 3 times 0 squared. What's 0 squared? 0. Negative 3 times 0 is 0. And then plus 3 times 0. So plus 0. So we get 0. Yeah, good. So our y-intercept is at 0. Domain and range. Well, to find our domain and range, I would graph it. A lot of us like to just graph these and then look at our domain and range. So I'm not going to do that one. Graph it and then look at your domain and range. Now, for the range part, though, you've got to be careful. This is going to be flipped upside down. Our y-intercept. Where did I go wrong? What did I do? Let me look at this for a second. So our y-intercept's at 0. Okay, that makes sense. Our max and min. Okay, we can find our max and min. Now, if we graph this, does everybody remember how to find max and min using your calculator? Are we all okay with that? Okay. So I won't do that then. This is going to be something like this. So it's going to cross the y-intercept here. Well, no, that's not true. Okay, I'm going to graph this real quick. So we have negative 3x squared plus 3x. Come on. So I go to y equals, my window's going to be off. So negative 3x squared minus 3x. Make sure you don't type in negative 3x or it will say error. Window, I'm going to fix my window real quick because I already know it's bad. And it's not that bad. Let's see what it looks like. Yeah, it's bad. All right, I'm going to fix it to the standard viewing window of negative 10 and 10. Graph. So then it crosses at, we said at 0 and at negative 1, so it's crossing the y-axis there. Also our y-intercept is 0, and it is crossing the y-axis at 0. Now our maximum point, we could find it by doing second trace. And you go down to maximum. Now you'd need to do this before you do the range. Super important, because your range has to be right on. So enter, enter. So our maximum's at negative 4.999, so that would be like negative 0.5 up 7.5. So our maximum value is at negative 0.5 up 7.5. So negative 0.5 comma 7, 0.75. So that was our maximum value. It looks something like this. That's our maximum value. So our range will start at what y point on this one? Where does it start on the y-axis? Look at your max. 0.75, very good. So our range starts at 0.75 and it's growing to negative infinity. So we'll write negative infinity first, so 0.75, and it included 0.75. So that one was a little bit trickier. That's why I wanted to go through that one. Any questions on that? Okay, awesome. Moving on, just a couple more. Solving something like this, I'm not going to go through the whole thing, but solving something like this, I promise you'll see one like this on the test. So look over here on the right. There's a lot of messiness going on here. So I'm going to simplify it. 2 is multiplied to all that stuff. I'm going to distribute it through. 2 times x is 2x. 2 times negative 3 is negative 6. Then we still have our plus x minus 2, which is equal to this negative here is like having a negative 1 in front. So we'll multiply it through here. So we have negative 1x minus 5. And then from here, we'll combine like terms on the left again. So we'll have 2x plus x, which is 3x. And then negative 6 minus 2 is negative 8, which is equal to negative 1x minus 5. And then from here, we're going to move x's from one side of the equation to the other. And we'll just go through and simplify this. Now, don't just float it over. You've got to use the correct operation. Now, this is what I'm seeing people do. Look up here really quick. I'm seeing people ask me, if you saw something like this, they're saying, now watch, because most of you are asking me this. Do I multiply that 2 through this? No. This 2 is being added, or this is being subtracted from 2. This 2 is not right here. If it was like this, if it was like that, then yes, you distribute the 2 through. Otherwise, no. We're just going to distribute that negative 1 through, and then 2 is being subtracted from all that stuff. I mean, this is being subtracted from 2. Does that make sense, the difference? So So if this 2 is not right next to the parentheses, don't multiply it in. I'm seeing so many of you do that. Okay, moving on. Okay, given the zeros, find the polynomial. Okay, looking at this, guys, we're given the zeros in this format. It might be kind of new looking to you. I think we have talked about this, though. So remember that this just means we have 3 zeros. So in the end, what's our degree going to be on our polynomial? Degree what? Degree 3, because there's 3 roots. So we have x is equal to 0. We have x is equal to -1, and x is equal to 4. So we're trying to find the polynomial given the zeros. Normally we're given the polynomial and find the zeros. We're working backwards. So remember, from here, we're going to work backwards. We're going to bring this over to this side of the equation. So 0, subtract 0 from both sides. So we have x minus 0 is equal to 0. That's a lot of extra work there. We're going to add 1. So we have x plus 1 is equal to 0. We're going to get all of them equal to 0. So I'm going to subtract 4. So I have x minus 4 is equal to 0. Now remember, we're working backwards here. Since they're all equal to 0, we can bring them together and multiply them. So we'll multiply those things together because we can say x minus 0 is just x, right? So I'm going to write this x. So we have x times x plus 1 times x minus 4, which is equal to 0. And now we can go through and multiply. Take my suggestion, guys. Take my suggestion. Multiply 2 of them together first instead of trying to do all 3 at once. You'll mess up, I promise. Promise you'll mess up. So let's go through and multiply this through. So x times x is x squared. X times -4 is -4x. 1 times x is x, so plus 1x. And then 1 times -4 is -4. Combine like terms before you multiply this x in. So we have x squared minus 3x. -4x plus 1x is -3x minus 4. And then multiply in that third x. And make sure you multiply it into the whole polynomial. So now we'll distribute x times x squared to x cubed. X times -3x is -3x squared. And then x times -4 is -4x. It's in standard form, highest degree, next highest degree, then lowest degree. So we're done. Your polynomials must be in standard form to get 100% on that problem on the test. Questions on ones like this, working backwards with zeros, okay? Couple more that I'm going to set you for your work. Looking at something like this, we're almost there, guys, and then you have the rest of the time, so it'd be worth it for you to just watch. 3y minus x is equal to 6. It says find the x-intercept. That's when what value is equal to 0. When what equals 0, can we find the x-intercepts? Tell me. Yes, good. When y is equal to 0. So plug in 0 for y. So we'll have 3 times 0 minus x is equal to 6. So we have 0 minus x is equal to 6. Now solve for x. 0's gone. We have negative x is equal to 6. Solve for x. Divide both sides by -1. So x is equal to -6. The y-intercept is when x is equal to -6. So you write x is equal to -6. Now if on a test, on the ACT or on my test, if I say put that in a point, think about it, guys. Points are in the form x comma y. You just found x, it's -6, and y was 0. It depends on how the question's asked. Questions? Okay. Now let's find the y-intercept. It's when what equals 0? When x is equal to 0. So this time, when x is equal to 0. So now plug in 0 for x this time. So we have 3y minus 0 is equal to 6. So we have 3y minus 0 is equal to 6. So we have 3y is equal to 6. Divide both sides by 3. So we have y is equal to 2. If you wrote it as a point, points are in the form x comma y, so we would do 0 comma 2. Yeah, no, you're good. I'm going to scroll up for you so it'll be higher for you a little bit. So once again, guys, y-intercept plug in when x is equal to 0. If it's the x-intercept, it's when y is equal to 0. If it's the y-intercept, it's when x is equal to 0. So it's opposite of what you think, but it is. Okay, awesome. Last couple. Looking at this, guys, on this level of math in secondary 3, we're doing advanced properties of exponents, and that's just the way it is. Some of you didn't get a good foundation with properties of exponents last year, so we need to go through this. You're going to see this difficult of problems on the test tomorrow. So let's quickly go through it. Now I'm going to sing my song. Well, first of all, looking at this, do you see any plus signs or minus signs in the problem? In the actual problem? No. Okay, good. No, it's just multiplication. So you sing your little song. When you multiply, you add. When you divide, then you subtract. Raise a power to a power and you multiply. But that's the powers. All that song has to do is with exponents, right? Okay, so let's go through and simplify this one. So I'm going to focus your attention right here first. So we have this stuff multiplied to this stuff. I'm going to focus your attention right here, though. We have powers being raised to another power, right? So raise a power to a power, and you multiply the power. So let's go through and do this. Now, careful. What's my power on -2? +1. Okay, so make sure you multiply the powers, not the number with it. That doesn't work. It's the exponents. So we have -2 to the 1 times -1, which is -1, and then we have -1 times 1, which is -1, so we have x to the -1, and then -1 times 3. Why the -3? Questions on that part. Now don't forget about all this stuff. We still have times 3x squared y to the -2. Now looking at this stuff, we're just multiplying all this stuff together. So we can reorder it if we'd like. So we can do, oh, this one's kind of tricky. So we have -2 to the -1 times 3. I'm reordering it. I'm going to put my x's by each other. So I have x to the -1 times x to the 2. And then I have y to the -3 times y to the -2. I just reordered it. Now, when you multiply, you add. But that's only if you have the same base. That's only if you have the same base. So with our numbers, 2 to the -1 and 3, you can't do that. This one's a little bit trickier. I'm trying to figure out which is the best way to teach you. But we can't combine those things. We can't just multiply those through because they're not the same base. So looking at this, we have -2 to the -1. Let's flip this over a fraction because it has a negative exponent. So we're going to have 3 stays on top, and then we have -2 to the +1 on bottom. I grabbed it, flipped it over a fraction, that whole base, so it's in the bottom. Does everybody see what I did there? That one's kind of tricky. Now moving on to x's. When you multiply, you add the exponents. So we're going to have x to the -1 plus 2, which is 1. And then when you multiply the same base, you add your exponents. What's -3 plus -2? Negative what? -5. -3 plus -2 is -5. So is everybody comfortable with here? Now we have to go through and fix any negative exponents, not negative numbers, negative exponents. Negative numbers are okay. So looking at this, 3 to the first, we're good. X to the first, we're good. Y to the -5. It has a negative exponent, so we're going to flip it to the bottom. When we flip it to the bottom, guys, it becomes positive exponents. So on top, I have a 3. I have an x to the first, which is just x. On bottom, I have -2 to the first, which is just -2. And now I have y to the 5th. Now I've simplified this all the way. Now on an ACT test, what you need to understand is they won't put this negative down here with the 2. They'll just float it out in front because it's the same thing. Because 3 divided by -2 is the same thing as just pulling the negative out in front. Okay, so I'll take this answer on the test, or I'll take the negative out in front on the test. Does that make sense, everyone? Kind of tricky, wasn't it? Yeah. Be careful with properties of exponents. Okay, multiply and put in standard form. I'm not going to do this, but I would suggest multiplying 2 together first, combining like terms, and then multiplying in x minus 2. Does that make sense, everybody? Don't try to do all 3 at once. You will mess up. Promise. Okay? Now, when simplifying this, guys, just be careful because you're going to see this on the test. We have this polynomial, and this time we're subtracting this polynomial. So we've got to go through, and a lot of you like to think of it like this, and I like it. They like to say, okay, that's a -1 in front, so I'm going to distribute -1 through, and then the signs are taken care of. So we'll have -5x squared, -1 times -3x will be positive 3x, and then -1 times -4 will be positive 4. Now don't distribute that negative. You already distributed that negative through. These are the signs, so you're good. Like, don't go back and subtract again. just write what you had in the beginning. 4x squared plus 2x, and then combine like terms. You took care of the negative when you distributed the negative 1 through. Does that make sense, everyone? So with subtraction, be careful. It'd be such a shame to miss this one on the test. And then you combine like terms and put in standard form. So let's just, I'm not going to go through and solve these, but on the test, like I said, guys, we've learned how to solve all these different types of functions, and you have to know what method to use. So we have x squared minus 2x is equal to 10. What kind of function do we have? Quadratic, so we have to make sure it's set equal to 0, and then solve for x. So x squared minus 2x minus 10 is equal to 0, and then we would solve using the quadratic formula, or factoring, right? Does everybody see that I subtracted 10 from both sides to get it equal to 0? Okay, awesome. Okay, looking at this one, we have x cubed minus 3x minus 10x. We have degree 3, so how many solutions are we going to have? 3. What do we have looking at 1, 2? We have 3 terms, but do we have something in common? We have an x, so let's write what we have left. So we'll divide each thing by x and write what we have left in the parentheses. X cubed divided by x. X squared, negative 3x divided by x is negative 3. And then we have negative 10x divided by x, which is negative 10. So I did this one on purpose because it's kind of weird. That is weird. You're right. So we have x squared. What's minus 3 minus 10? Minus 13, which is equal to 0. And then from here, we can set each of our factors equal to 0. So x is equal to 0. There's one of our answers. And then x squared minus 13 is equal to 0. Can we solve that one pretty quick? Yes. So we would add 13. Since we're missing the middle term, missing dx, I would suggest just isolating x squared and then taking the square root. So add 13. So we have x squared is equal to 13, then take the square root of both sides. So we have x is equal to plus and minus the square root of 13. Then you go up to the side and see if that simplifies, and it doesn't. There's 1, 2, 3 answers. Questions on that one? Okay. This one, what method should we use to solve? We're down to our last 2, 3 examples here. I'm not going to go through them all. These will be quick, and then I'm going to let you work. Which method would we use to solve this one? Somebody just said it. Grouping. You knew you would use factoring by grouping because there's 4 terms. So you'd group the first 2 terms, you'd group the second 2 terms, let's factor them, and then we'll be good. So in this group, what's in common? Greatest thing in common. X cubed. So then when we pull out x cubed, we have x minus 3. And then looking at this, what's the greatest thing we have in common? 2 and x. And so when we pull out 2x, what do we get right here? X minus 3. Are we safe? We can truly use factoring by grouping, so we're safe. So we'll pull out x minus 3, and then left is x cubed plus 2x. Is everybody comfortable with that one? Now set each of those equal to 0 and solve. Now look how easy this one happens to be. Really quick. We'll set x minus 3 equal to 0 and solve, so we get x is equal to 3. We set x cubed plus 2x equal to 0. Now is this a quadratic? No, so we can't solve using the quadratic formula, but what do we have in common? An x. So we'll factor out an x again, and we'll get x squared plus 2. Now we can set each of those equal to 0. So we'll set x equal to 0, and then this x squared plus 2 equal to 0. And now right here we have a quadratic, and we can continue to solve. That was like a 4, 3, 5 step problem, right? Does that make sense, everybody? Okay. Okay, looking at this one, how do we solve it? Can we just subtract 64 and then take the cube root of both sides? No, this is the sum of 2 perfect cubes. So we have to find our front term. Take the cube root of x cubed, and you get x. That's our front term. Take the cube root of 64, and our back term is 4. And then we go through our little thing to factor it. So we'll have x plus 4. The sign stays the same. Then we do the front with the front. So x squared, the front with the back, so 4x, and then the back with the back, we have 16. This is plus, so we'll change this sign, and then this sign's always positive. It stays the same. Then from there, set each of them equal to 0 and solve. Okay, looking at this one, we have 12x to the fourth minus 4x cubed minus 8x squared. We would factor by pulling out what we have in common, right? So what do we have in common? Greatest thing. And x squared and what else?
4.
So 4x squared. And then we write what we have left. Go back and divide each thing by 4x squared. So then looking at this, what's 12 divided by 4? 3. So we have 3x squared. Right here we have minus x. And then what's 8 divided by 4? So negative 2. And then we'll set each of those equal to 0 and solve. Right here and right here, right? Are we all okay with that one? Okay. All right, do worksheet. Now fix the instructions on 19 through 24. It says multiply, but you're not going to necessarily be multiplying all of those. Some of those you're going to be adding and subtracting. I meant to change that to just simplify. So just don't be like, oh, it says multiply, so I'm going to ignore the fact that we're not multiplying and multiplying. Do what you're doing there, what you're supposed to do. Does that make sense? It says multiply, but half of them you're adding and subtracting. Now it's out of order because I messed up and did one-sided to two-sided wrong on the printer, so that's why it's out of order, so I apologize. I would go in the order. I would go 1, 2, 3, 4, then go on to 5, 6, 7, 8, 9, and then go back to the front. Yeah. Anyways, finish the worksheet. The rest of the time is yours. Guys, the test is tomorrow. The test is tomorrow. But I'm telling you, if you can do this test review, and you know what you're doing and you're getting them right,